Hey guys, so for this tutorial, what we gonna do is we will create a path and specific into a specific direction. We will create an analysis, and the radiation will go to the adjacent path or a junction and spread it all over the building blocks until there is some kind of obstruction. So in the previous video, we did it from the point, and for now, we'll create a path and using this script, we will create multiple points and take that into a specific direction. So for that, we don't need these points. So I will delete this, and for some time we can disconnect this preview and take it to side. After that, what we have to do is create a layer name path and make it a current one, and draw the path into the Rhino model of a specific street you want, as in to show the flow, and based on that we'll create actual flow and after that we have to assign this curve into the model. So we will use curve, select the curve, yes, and after that we will divide curve into an individual points. So divide curve, for that pass on the curve, enter the number of divisions you want. For now we will take 25, so that we can decrease or increase it, and the output comes as point tangents. So tangents can be used to give direction. So for the previous one, what we did was assign a plane to a particular point. So for this, we will have to add numbers of plane. So for that, we will create line SDL to give this tangent line and line. The length of the line can be, doesn't matter, you can take as anything. It's just for the reference to create the plane. So as you can see here, the perpendicular lines and the line in specific direction is created in direction of the curve. So we'll need a perpendicular line to create a plane. So for that, we will rotate. Rotate this geometry line, create angle as degree. Through the panel, you have to manually write the angle over here and pass it to and plane. So for how many points you have to create the plane. So it could be on the number of counts. So I will take the division of curve into this. And yes, you can see the perpendicular line has been created. So after that, we will create a plane from it. From these two lines, so we'll go to intersect and vector, plane, and line plus line. So first line is this, and second line is the rotated one. So we can find this. There's an error message. Input B. Okay. Yeah. So we got this plane. After that, what we can do is pass on this plane to the Isovist planes to run the command. So I will pass on and see if it find the point. I cannot view the points, so I will, yeah, preview because it was off. So I got this off, but it is in 360 direction. So to create into a specific direction, I just have to enter the range of domain. So this can be 0.25 to 0.75, which is here coming this way. So what we can do is it should be 0.5 to 10. Yeah. So it's moving in direction of the path here. So after that, we can pass on this data to polyline and can review it off now. Boundary is off. And after that, we can increase as everything is set up, you can increase the count. And if you want to flip the direction rather than changing the domain, you can, what you can do is flip curve, pass it to here, disconnect to the main connector and divide it afterwards from the flip converter. So you can see the direction has been flipped. We haven't used the domain. So from here, you can increase the number of count. The heavier the count, it will take some time. So you can adjust it from here. You can see how much it is lagging because of the number of curves and the divisions. So we can now preview it of the perpendicular lines, plane, points, and this line also below. From here, you can change the representation of line as you want to show. You can also add another curve to see how the junction works or a simulation of it. Select the curve and you will get the both in both the directions, and you will get a junction which will be viewing in 4 directions, a pathway going this way and a perpendicular one. So here you can see if you're passing through this lane, you have major opportunities of creating this landscape because the building blocks are blocking this view. but there isn't any obstacle over here. So this can be converted into a public space or uh, an area which makes people flow into this area, square. So if you have an eggshell or urban pattern which creates a plaza, then mostly this kind of analysis helps you in designing streets and laneways. So just hide it. And after this, you can make this preview to the fourth layer group. Okay, preview it. And after that, from here you can change the output and the opacity. You can create and base play. You can change the theme, and yes. So I will show you the output result, and you can follow this instructions to create an urban flow diagram. So here you can see I have created another diagram which leads you to a specific point, and it shows the two main laneways connected and how the flow is meeting the plaza point over here. So you can generate this kind of diagram and render it or export this all layers into into an individual layers of path building blocks, and after that you can render it and use for the simulation.